Hello, everyone. Welcome to this week's TAF. My name is Jayan, assistant professor in the Web Information Systems group at TU Delft. So nice to see some of you again, and welcome to other new members. Now, this speaker series will look at human-centered AI and specifically focus on the knowledge and language aspects of human-centered AI, which are actually, key concerns in making AI system understandable to humans and allowing humans to interact with AI. And we specifically, we specifically look at human-centered AI, right? Which I believe most of you have heard about the term in many different places. The goal is ambitious, which is to design and develop AI systems that can support the human activities in a reliable, safe, and trustworthy manner. We have already organized 3 editions of the Academic Fringe Festival in the past, and you can find the videos on our website. Now, this week, I'm thrilled to introduce our speaker, Anja Thieme, if I'm pronouncing your name correctly. Anja is a senior human computer interaction researcher with Microsoft Health Futures in Cambridge, UK. Her research follows a human-centered interdisciplinary approach to the end-to-end development of innovative AI systems for use within real-world healthcare. And more broadly, this work enables her to define strategy and the processes that ensure AI technology is developed safely and responsibly. Now, among others, this is reflected in her contribution to Microsoft Ether working groups and the development of educational tools and other resources with members of the Office of Responsible AI that seek to drive forward the adoption of responsible human-centered AI practices. Today, Anja will introduce her work on human-centered AI in mental health. Again, to all the participants, feel free to ask questions, but using the chat in Zoom during the presentation, and after the presentation, you can unmute yourself for questions. Now, without further ado, let's welcome Anja again, and thanks a lot, Anja, for being here. The floor is yours.
Brilliant. Thanks, G. And also thanks for having me join today and being part of this great talk series. So yeah, you've already introduced me. So really the focus of this presentation is on the topic of human-centered AI in mental health. And specifically, I want to talk to you about a project that was called Project Thalia. So that project was a 3-year-long research collaboration between Microsoft and a company called SilverCloud Health. And they provide basically access to online mental health treatment. And this research collaboration generally was operating under the overall mission to drive forward the development of AI that would help more personalized mental health treatment. So really under how can we create AI solutions that might help more personalized care provision. And that was sort of based on the trends at the time when the project was starting, where there was a huge increase in research and AI development in the mental health space. But a lot of the work would look at how do you assess mental health or mental health status. So you would find examples of sensor data on mobile phones being analyzed or social media data to either better understand mental health of people or detect and automatically diagnose a particular mental health status. And there was also some work on predicting mental health risks, especially suicidality, but there was a lot less around looking into how you improve the digital delivery, for example, of psychotherapy interventions or, support more personalized care. So that was a lot less investigated. And it happens that our partner, SilverCloud, was also very much focused on providing a good personalized experience to people who are experiencing mental health difficulties. That's the core mission of that company. And so that made us focus on how could we provide personalized care through AI in this context. Before I go into sort of some of the explorations we did, I want to give you a little bit more background on SilverCloud, what it is and how it works. So SilverCloud as a company provides access to online cognitive behavioral therapy, CBT. It's quite a prominent psychotherapy format, and it's predominantly used for the treatment of anxiety, depression, and stress. It's really one of the leading platforms in the space. They've got a bit more than 1 million users so far, and there's a wealth of data of how people use these digitally delivered treatments. And amongst sort of the various 30 plus programs that SilverCloud is offering, these are sort of the 5 ones that you see on the screen. And the space from depression and anxiety is the one that has the largest user base, and therefore has been a focus of much of the research and machine learning development that our team did during the project. Now, how does it all work? Let's say we're based in the UK. So let's say in the UK, you approach your doctor, your GP, your general practitioners with perhaps mild to moderate symptoms of depression and anxiety, then they can literally prescribe you access to Silver Cloud as a treatment. And then this treatment program, you access it online. It's pretty much self-guided. That means you yourself have to work through the therapy content in your own time, perhaps after work every day. And so it looks a little bit, when you log into the platform like this, you get access to, let me see if you can see my cursor, to 8 program modules. And then each of these has sort of a number of information pages that teach you basically how your thoughts, feelings, and behaviors are interlinked, and how you can potentially break off unhelpful thoughts. And then embedded within these pages are also a set of tools. You can imagine like exercises that help you translate the learnings into practice and apply it to your own life. And as you can imagine, the more time and effort patients bring into working with the program, the more they tend to get out of it. But this is also part of sometimes the problem. You know, a key challenge can be, how do you keep patients engaged and committed to the process and to complete these therapeutic programs? And a key element to help with that is that patients are guided throughout the treatment journey by a specifically trained human supporter. So it's a real human being who communicates with each patient once a week, maybe bi-weekly, and they do so via online messages. It's an asynchronous format. And their role is to basically help the person work through their difficulties, maybe give recommendations of what treatment contents to focus on, and basically overall ensure a good patient experience. And as you can imagine, you know, research has shown having a human in the loop in these kinds of services leads to better therapy engagement, and as a result, also better patient outcomes than unsupported interventions. Now, for these supporters to review a patient and how they progressed week by week and deliver basically this personalized support, they have a specific intervention management side. So this is a little cutout of how this looks like within the UI, where they have basically a patient dashboard with data items that's already been collated. So you see here to the left a lot of sort of metadata about how often has the person logged into the program in the last week, how many content pages have they looked at. If you clicked on it, you saw details on what kinds of contents, here's the tooling and what entries they've had, if they communicated with their supporter at all or not. And so reviewing this data, in response, the supporter then writes a personalized feedback message. They can use certain templates, but they try and adapt it as best as they can to the person, and then schedules another review meeting. And this whole process is done really quickly. So it tops 15 minutes a person, so not much time at all. And I think it's quite important to mention that as part of this, there's also clinical questionnaires that the patient completes to assess their mental health symptoms. So these are often the PHQ-9, which is a standard clinical assessment for depression symptoms, and the GAD-7 for anxiety symptoms. And in this format, and the data that we looked at, within the NHS in the UK, when you're registered and you're signed up for treatment, it's basically a requirement during treatment that patients complete these clinical questionnaires every week or bi-weekly. So that the fact that it's mandatory means you've got pretty good complete data on those items, and it's routinely collected. And what's also quite nice is that any interactions that the patient has within the digital treatment, what they look at, when, how often, it's all recorded by default within a huge database. And so these patient interactions are also accessible to us. And that's a huge advantage if you think about, you know, we have mental health outcomes week by week. We know what people have been doing on the program. It makes it sort of easier to imagine and practically more feasible to integrate machine learning insights, or either derive them and then also integrate them within the data configuration that already exists. And so this is we saw this as a huge opportunity to think about not just AI innovation, but also how do we translate these advances potentially into the real world and could integrate whatever machine learning prediction we might derive into something that exists in real world healthcare provision. So that was quite an exciting entry point for us within this collaboration. And so, yeah, our aim was, how can we embrace this opportunity? And given that these human supporters are so important in this context, we wondered how machine learning insights could assist these ICBT supporters and enable them basically to provide more effective personalized care to their patients to help improve overall patient outcomes. So that was what was motivating our work. I'm going to touch on 3 explorations. The first 2 I will cover a little bit more briefly, so I'm going to go a little bit more detail on the third. So here, the first one that I will talk about was a little bit driven by curiosity about what types of insights we could derive from the rich program use data that was available to us. And I should say all this data, everything that we worked with was fully anonymized. And so the idea was, okay, what useful insights could we derive from this data that supporters could leverage to provide more personalized care to their patients? And here we went with a curiosity question of, could we identify different types of program users? So are there any typical patterns of how patients tend to engage with treatment? And what is it that they have in common? So are there different sort of types of program engagers, and where are the differences? And the idea was that if we could identify those different clusters or types of users, if we had a new user and we could early on predict what type of engager they are, we might also be able to see how does that correlate with better treatment outcomes and customize content or interactions according to that engagement type. That was motivating this exploration. And so to surface these different types of treatment engagers, we analyzed interaction data of a bit more than 54,000 patients. They were all part of this depression and anxiety program that I showed at the start. And we also had their outcomes, their mental health outcomes at the end of typically a 14-week treatment period. And these were used as inputs to a hidden Markov model. And that ultimately revealed 5 distinct user groups. So you see here, the groups differed in treatment trajectories and outcomes over time. So one is how they engaged over time, and one is what were sort of the reductions in symptoms of PHQ and GAD. That's what's shown here. I'm not going to go into detail, but what I want to highlight is sort of some high level things. So for example, we have here class number 5. That's one type of group where engagement was highest throughout. And interestingly, even those people engaged the most with the program, they were not the group that had best improvements. That was instead class number 3, the green line here. And that basically would, for example, suggest it's not just about more engagement leads to better outcome, but it matters also how people engage and the nuance within it that might explain why the people who engaged in this way with the program tended to do better. And so we had a closer look as to what differentiates these groups. And we're trying to kind of decipher meaningful patterns that you might see in the differences between the groups. And these are sort of quite high level things. Again, I don't expect you to look into detail here, but one of the things, for example, you could derive from looking a little bit more into detail is that those class 3 engagers that tended to do best, for example, most often completed take-home points on the platform. Now, take-home points, for example, are things that you do typically at the end of a content module, and you might interpret this, it might suggest that these might be people that more often than not completed certain modules and perhaps did more so than members of other groups. But it's quite hard to derive anything sort of meaningful or feel comfortable in the sort of conclusions you might draw from these patterns in isolation. It allows you to develop hypotheses, but they will need further testing. And we also looked a little more closely at the types of contents or tools that were used by the different user groups. So here you've got blue, basically indicates a particular program section. Red is all the tools, and green are the various content pages that somebody could have looked at different time points. And again, it's quite, you can see there's subtle differences between the classes, but it's hard to derive meaningful insight. I mean, you can see certain things like, again, class 3 is our best achieving in terms of mental health outcome class. And you can see, for example, that there is a tendency to do content in a little bit more of a linear fashion. But it's nonetheless quite difficult to draw any robust conclusions from these patterns that you can then sort of package up in truly actionable insights and useful guidance that supporters will work with day to day in their work. So it's not been that trivial to do well. And so this is the first exploration. I know I'm going quite quick, but if you have any questions on those projects, I'm happy to answer them at the end. So a second exploration that we did was to also look a little bit more closely into the messages that supporters write to their patients each week. So I was saying, you know, they review their interactions on the platform week by week, and then they compose a personalized feedback message and response. And we wanted to see what characterizes these messages, and what particularly characterizes the messages that supporters send to patients who have pretty good outcomes at the end, as opposed to those who might not benefit as much. And maybe we can learn about what characterizes good communication or effective or very supportive communication. And so the way we did this, as a first step, we clustered supporters into 3 groups. So we had groups of low, medium, and high success based on whether the messages were linked with better patient outcomes. And then we would compare what distinguishes the messages of the high success cluster from those in the low success cluster. And we would look to do this analysis, we look at semantic and linguistic features in the data. And that's sort of the various ways in which we compare the messages. So I should say again, we had no access to the actual text messages. So all we could do is work with sort of very high level, abstract, anonymous text features. So we would, for example, be able to look at what's the count of positive words in the text messages, negative words, you know, how many words related to certain emotions have appeared. Now, the things that you could derive from pronoun use. So are you perhaps more directing things at the person? For example, you should be doing X, you should be doing Y, or are you more using first person plural pronouns, where you might say, we can work through this together, and kind of speak a little bit more to a supportive alliance between supporter and patient. You know, text length even was a marker. So very general ways in which to extract features from those texts. And then we basically looked at, okay, so how are the text communications along those features different for the high versus low success communication clusters? And what you can see from this is, again, we learned sort of that in general, concrete, positive, and supportive feedback from supporters that in particular references social behaviors was basically most strongly associated with better patient outcomes. And you can see, you know, words here, this is what this shows, words relating to social behaviors. If you had more of these words, this was related to better outcomes as opposed to less words of that. And abstraction was the opposite, you know, the less abstract words you had, those messages tended to correlate with better patient outcomes, if that makes sense. And so, yeah, again, a good plausible finding, but we wanted to go one step further and want to, you know, how could you adapt this even more to a particular patient, right? These are sort of in general insights, or in general seems to be correlated with better outcomes. But what if you wanted to personalize communications even more so that to that individual person's circumstance? And so taking this a little further, we then used an association rule mining algorithm to extract more context-specific patterns with regards to these communication features that we had extracted. And so here we mean by patient context, for example, okay, so what matters in the communications, depending on how engaged the patient was, for example, with the program, how far along they were, what were their mental health symptoms at the time, and so forth. So there's different features you can bring in. And then through that mining approach, we achieve basically 1,584 rules, which is what's plotted here in the heat map. So each of these little squares reflects one rule. I'm going to give an example to make this a little bit more tangible. And from these rules, you can, for example, identify certain trends and variations in communication that basically characterize successful messages in relation to a patient-specific context. Let me show you this through an example. So zooming in a little bit more. So here at the bottom, we have for each column represents a different patient context. And that is a combination of, like here, the first 6, for example, are patients who didn't engage with the treatment program at all, have shared very little or no content with their supporters, how far along second, third, or fourth week of treatment they might be in, what their mental health symptoms are at the time. So each row is a unique configuration of different patient characteristics. And then on the columns, and then on the rows, you see the linguistic features and whether they appeared a lot, medium, not a lot, medium, or high within the text communications, and whether that is associated with good outcomes, which is green, or salient in particular in messages that were less often successful in terms of patient outcomes. Again, you know, you can look into these patterns and see shifts, for example, between, you can see a break here between people non-engaged and engaged that changes what types of words or frequencies might lead to better outcomes. But again, you would have to do extra work to kind of try and evaluate and validate these patterns properly. And we did not have access to the real text. So it made it really hard for us to, again, derive claims that we could properly validate and put this into actual use, which is what drove a lot of the project. We wanted to identify something that wasn't just, yes, this is a great avenue to explore, to try and identify how we can personalize messaging potentially more effectively. But we also needed to feel confident that the results that we were achieving and interpretations we would draw from this are valid. And that was very hard to do when you can't see the actual ground truth text, to be confident that you draw the right types of conclusions. And so we did a third exploration. And this is what I wanted to spend a little bit more time on. So my apologies that I was pushing through these first 2 quite quickly. But as I said, there's papers underneath each of them, and I'm happy to answer questions. So yeah, we went back to the drawing board because we wanted to achieve something that works sort of well with the data limitation that we had, and also that really would enable us to move closer to having machine learning outputs that could be used in practice and really implemented. And so in our third exploration, we settled on predicting patient outcomes early within treatment. That was a choice for a number of factors that came together. So the idea, for example, stemmed from the clinical literature, in particular feedback-informed therapy, which basically suggests if a clinician knows early within treatment that a patient isn't on track to achieving the desired outcomes from treatment, then that enables them to make necessary treatment adaptations to try and better meet that person's needs. So within the context of Silver Cloud, a supporter could, for example, increase how often they meet with a patient, provide feedback more often, especially if they are not predicted to do well. They might work a little bit harder to identify blockers for improvement for that person. Or maybe they decide, actually, you know, the treatment program isn't working, the person should be moved to a different program, or maybe an entirely different treatment approach. And equally, if the prediction was, okay, here's somebody who's likely going to do well, who's going to get desired outcomes from treatment, that can feel reassuring that the treatment is working and that the supporter can continue with it. So it can either flag up something isn't right and investigations of what that might be, or provide reassurance and confirmation that people are on track. And that can also help with how you might prioritize where you spend your time as a supporter and who needs most attention and support to achieve ultimately desired outcomes. And so we also did user research, I should say. We did an interview study with 15 ICBT supporter, from which we learned, amongst many other things, that they are actually really interested in each review point to really understand patients' mental health progression. And we also had, given that what I said at the start, that sort of PHQ-9 and GAT-7 assessments are sort of mandatory throughout treatment, we also had really good data availability for modeling outcome prediction. That's really that combination of these various factors, oops, my apologies, that brought together this focus on predicting patient outcomes. And so the team built a recurrent neural network architecture and basically developed one binary outcome prediction model for PHQ, that is the depression, assessing depression outcomes, and one for GAT, that's the same architecture. And the models are basically trained on symptom trajectories of over 46,000 previous users of the Space from Depression and Anxiety program. And having fed that into our RNN, the model is then able to predict at each time point in treatment what will be the outcomes by the end of it in terms of depression and anxiety. In this particular instance, we are predicting an outcome that's called reliable improvement. And that is sort of defined as a reduction of depression score. So your depression symptoms are measured via a questionnaire. The PHQ-9 has, for example, 9 questions. Each question gets a score. It gets accumulated to a total. And if that total score is reduced by at least 6 points or more by the end of treatment, it's been defined as a reliable improvement, a significant clinical change. And that's sort of the success criteria that, for example, the National Health Services in the UK use to assess success. And for the GAT-7, which has less question items, it's a reduction of 4 or more points. And we went with those established definitions. So our prediction model then showed that actually 1, 2, 3, so after 3 questionnaires being responded to, that's sort of 3 to 4 weeks into treatment. The blue line indicates here the performance of our depression predicting model, and here the blue line is for anxiety. And after 3 to 4 weeks, it predicts fairly robustly, sort of around 87 or more % the outcome, and does better than other baselines. So at this moment in time, when we did this work, we felt this, and the clinicians who were working with us felt this was good enough to think about, okay, what would this mean if we were to put this into practice? It's a good enough performing model. What's next? How can we make this be something that is useful to clinical practice? And so I think there was a bit a question, okay, what does having this binary predictor, what would be the utility for clinical work? That was an open question. And you could argue to a certain extent that it's quite a simple predictor. It's a binary flag that indicates somebody is likely to improve or not. And on the one hand, we thought this was seemed quite low risk, at least, to think about deployment, or at least lower risk than providing, for example, really concrete clinical recommendations, because we could give more context, we could model something else on top, but then what would be the implications if those insights were wrong? But at the same time, having this binary predictor, you don't get any context as to why the person might not be improving or how you go about addressing whatever the problem might be. So it's this sort of balancing between, you do want to provide an insight that has a lot of clinical utility, but you also want to manage the risks of potentially having a false prediction and people either, over trusting a potentially false prediction, or I lost my thought there. But you do, I leave it at that. So it's a balancing act between you want to be thoughtful and careful in what you put into practice, especially if this is new territory and you're actually trying to integrate something into an actual healthcare service. So we stayed with something simpler. Nonetheless, we wanted to learn, what could be the utility? How would supporters anticipate using this in practice? So we went back and did design sessions with 13 supporters, really try and follow a human-centered approach in this project and learn a little bit more. What could be the challenges for integrating these machine learning insights into routine clinical care? What are the worries that people might have? Include any questions of how should this information ideally be presented so it's easy to comprehend, but also manage risks of over-reliance, and what would that look like? And to help participants, these ICBT supporters, to help us answer these questions, we showed them a set of different design mockups. So created multiple mockups and then narrowed it down to those 5. And the idea was here that it sort of illustrates different ways in which the AI output could be shown within the user interface. And these visuals were distinct in a number of ways. So the first 4, for example, would be shown in relation to an individual patient's profile, whereas the last one would show all the patients in a cohort of a supporter, and you could compare, for example, predictions across. Maybe this helps, for example, with selecting who you might give most attention to, for example. But we also varied as to the extent to which we created explanation and context to a prediction, how we presented it visually, graphically, text-based. We're including indications of uncertainty, numerical values, color grading, different ways in which to try and implicitly and explicitly communicate the robustness of the prediction in itself. And from this, we learned a number of things. So amongst others, these supporters had a really strong preference for a very simple visual indicator of the prediction, something that they literally could just grasp at a glance and that they could expand on to learn more. We learned there could be a lot of time spent for some people to get hung up on small variations of numbers. So, for example, from one week to another, why is there a difference between 83 or 85% in a prediction? That doesn't necessarily need to be sensical, but people could get hung up quite a lot on those numbers. And so, for example, we made the decision to leave any numerical detail in a sort of extension, and you have this very simple visual indicator in its own for most of the UI, and unless you ask for explicitly for more content. Equally, to not overwhelm with too much detail up front. You know, a lot of the context information, for example, what the prediction is and how it was derived, is sort of accessible on demand. And we basically follow this design pattern of progressive disclosure. So on demand, if more information is needed, the information is available, but not to overwhelm in the first instance. Now, obviously, this focus on keeping it really simple and digestible at a glance means there's less scope to provide additional model explanations that could help with transparency and also help supporters assess whether the output could be trusted or maybe false. And we also found that in practice, you know, having additional explanation of the prediction itself, or maybe how even the model derived that prediction, it assumes sort of a technical expertise and an interest to want to interrogate AI outputs. And really, the supporters, you know, they're working on a high caseload, in a fast-paced environment. It's an emotionally stressful environment. They have very little time, so to pause and reflect about the data prediction itself any further, right? Their first concern is the care for the patient, how they can provide the best, you know, support in the limited time that they have. And so engaging deeper with the AI model outputs is not really a central concern. And of course, that can amplify tendencies to overly rely on the prediction. You know, you basically have no chance but to accept and trust the data as is on face value, where supporters might treat the prediction as a shortcut in decision-making. You know, they may disregard as a result other important information that they could have about a patient, become less assertive and attentive to the patient needs. At least that's a concern that may arise as a consequence of that. So, yeah, we were obviously then confronted with how do you counteract this overtrust in this simple binary indicator. And for that, we discussed this a little bit with the supporters. We learned you should try and balance the machine learning data with other assessments and information that a supporter might have about the patient. And so for this reason, we chose to embed the prediction, shown here, within sort of the patient profile that's visible here at the bottom. So you have those information alongside each other, so you can start to triangulate whether the prediction makes sense given all else you know about the person. So that was a really important consideration. And of course, training plays a key role. And I don't just mean onboarding, but also how things become embedded into practice and explained as part of everyday care provision within this format. And so here, supporters, for example, recommended that learnings on how to use the outcome prediction as a data item should be embedded within existing supporter supervisory relations, where basically supporters learn how to interpret other data sources as well. So you could take the example of, you know, these clinical questionnaires. You know, PHQ-9 scores in themselves are also in a way reductionist, right? They present an approximation of how depressed a person might feel, but they don't give you a complete picture of what could be a quite complex mental health experience of the person. And yet, you know, even a clinical questionnaire could be a useful indicator, you know, and basically the suggestion was the same way that These traditional clinical questionnaires are data items with their strengths and limitations. The suggestion was that prediction outputs could be treated sort of along similar ways. They have certain benefits, as in FLAG, but they also come with their own limitations. And then, of course, I'm not saying onboarding isn't also very important. There can be a key opportunity here to introduce supporters to what even machine learning is, how the model was developed, give a greater sense that outputs are probabilistic and can be false, and remind them of the limitations of those insights. It's unlike other statistical approaches. Yeah, but it can be a real tricky balance to cut between communicating transparently about risks and limitations, and at the same time convincing others that there might be value to it and that you are providing insights that are truly useful and can be relied upon. So that's a constant tension between, yes, there's opportunity, but there's also limitations. And so when we discussed those various opportunities, we learned that for establishing trust in machine learning, there are quite a few other mechanisms at work in those kinds of contexts. So, for example, in general, we found that the supporters really appreciated the fact that the models were trained on quite large scale, but also highly relevant data. You know, the fact that it was 46,000 previous SilverCloud users who exactly engaged with that treatment program made this for them a very credible resource that the models learned from. So that was a trust factor. They also had a strong belief in SilverCloud as a trusted provider, basically trusting them to do the right thing. So if SilverCloud chose as a company to implement such a tool within their service, that sort of gave it sort of some form of accreditation. And then, of course, trust also becomes established through other clinical relevant resources. So in clinical, this could be clinical evidence provided through randomized controlled trials. It could be peer review in clinical journals, other approval agencies, things like FDA approval, that would basically provide known and understood seals of approval that a technology has been trialed and tested and is safe to use. It seems a lot more potent and powerful and understood in these kinds of contexts than explainability techniques that come from the AI community that might be more technical or more model focused rather than perhaps as human-centered within everyday practice as other ways in which to implement those things. And so clinical professions would look for these other types of evidence. And of course, trust also is something that becomes established through use. And as each person assesses the actual performance of these models when they use it over time. So I just want to share with you one quote that stood out a little bit because it's sort of quite a pragmatic view on both the limitations of AI, but also the prospective utility of it. And so here's somebody saying, you know, well, it can only be correct X% of the time, right? So I don't bother. It don't bother me if it gets it wrong. It's telling me it's going to get it wrong. It's just the best that it can do based on loads of data, which I don't have otherwise. Machines make false predictions. It's just saying 9 in 10 people. So 1 in 10 times it's going to give you a wrong prediction. For that individual client, it's a pain, but that's IAPT. So IAPT is the overall NHS service that provides access to SilverCloud. You have to make these decisions anyway. At least you're getting it right 90% of the time now instead of, 60%. It's about improving my decision-making, isn't it? Can this improve my decision-making by 10%? If it gives me a false prediction, but overall, I know my recovery rate increases by 10% and clients are getting better, then I'm happy because patients are always not going to get well. So it's sort of putting things into perspective, and can we overall show that it is making a difference across the patient cohort? And obviously you want to do this fairly and so forth. It seems like a very pragmatic view on working with the limitations of AI that surfaced. So just to bring this to a close, so from the learnings from the various user research and design study, the UX team at SilverCloud were then able to develop a first proper user interface design. I should say by that point, our collaboration had drawn to a close. And then SilverCloud ran a pilot on a fully working implementation within the service. And then from that pilot and some improvements there, they actually run and conducted a larger RCT trial involving over 2,000 patients that was recently completed. And the study in particular focused on clinical effectiveness metrics, but it was also there to learn about AI impact on workflow adaptations. And we're very much looking forward to hearing and reading about the results from that study. And so, yeah, just to conclude, I was drawing on these examples, especially the last one, to highlight really the importance of a human-centered research process. So speaking especially about the sort of ways in which we try to identify what types of machine learning predictions and applications to develop that could bring real-world utility and balance that with risk. And I also wanted to really draw a little bit attention to the role of design and workflow integration, as these quite considerably can moderate AI acceptance in those application contexts. Yeah, and with that, I would like to just thank the overall team. This is just the core team, but there have been many others involved along the way. I'm happy now to take any questions.
Thank you, Anja. Yeah, we have one question already from the chat. Chadda, you want to speak out yourself, or I can simply repeat for you? Please, just, yeah, unmute yourself.
Yeah, I just wanted to ask, you were talking about mitigating overtrust and over-reliance, but I was wondering if you at some point considered actually measuring the extent to which people overtrusted or undertrusted the system, if you had kind of like a baseline from which to compare their interaction, or if that was something that didn't really work for your context.
It's a really important question. We did not measure, we didn't do any quantitative studies or measure overtrust, or even try to conceptualize what that means. I think we were just more qualitatively exploring what are the concerns, where could overtrust, what could be the source of overtrusting, and how would you potentially mitigate that? So it's more of a study of understanding, but it would certainly be something to look into, especially, you know, RCT was focusing on clinical effectiveness. This would be a different kind of study that would probably be very worthwhile to conduct in the future, but it wasn't part of the scope of what we did.
That's interesting. Thank you.
Thanks.
Just coming out of the screen share to see you all a little bit better.
Yeah, this works nice. Do you have any other questions?
I do have one, probably. Oh, sorry, Willem, you want to go ahead?
No. All right, I will throw one question.
Please.
Okay. So you did some analysis in the middle. I saw your paper. And do you have also a bit of an indication how large these impacts are? Because lots of these studies, you're happy to find something significant, but it's so tiny that it's not really practical relevant to even bother about. So, for example, when you looked at these different messages and the kind of content and the features.
Yeah. I mean, we've only reported on all the features that don't clearly stand out as a significant difference between the low and the high impact clusters. But then you would want to run a different type of study where, you know, you wanted maybe to translate this into some sort of, we imagine something like a smart message writing assistant that might indicate, oh, I didn't even know how you do this very well. I think it would need a lot of thought, but where you might suggest, maybe include some more words relating to social behaviors or calls to action, or include more words of encouragement. And then you would want to see what would over a certain amount of participants over time, these adaptations lead to better outcomes indeed for those individuals or not, and which adaptations to the text and the characteristics of the text would have brought the results, and what would be the effect size. So it's only been based on historic data, and from those there were very clear differences that we identified, and those are reported, but what the effect size would be in practice.
No, but just already the effect size that you found yourself between the different groups, if you see this feature.
Yeah, especially the one that I did show on, for example, words of abstraction, social behavior. I think those differences were quite clear. I mean, there's sometimes 2 words extra, which doesn't seem a lot, but the messages are fairly contained. So there should be some strong
And did you also find something for dropouts? Because all this online, you also have this huge dropout of. So are there indicators what stop people from dropping out?
This is a really tricky one because we discuss dropout. Dropout is generally tricky because how do you define dropout? Especially in this context, people are using the platform at different time intervals. So some do it weekly, some bi-weekly, in terms of when their assessment cycles are. So there's already a variation between somebody maybe using it 8 weeks but very successfully, or somebody 16 weeks equally successfully. So. Yep. And there's maybe some people who may only use it for 4 weeks, but get everything out of it that they need, and they just connect, but they might not be counted as dropout. So even defining what dropout actually means reliably, we found really difficult. And it's also that even though your treatment might be complete, you can still continue and come back to the platform. I think it's available for another year or 2 after treatment has completed. So because you may have learned to use certain tools that help you really well to manage your mental health. Mental health is something you manage perhaps throughout life. And so when people engage and disengage, it's sort of a little bit more complicated. So even just the definition of dropout is actually quite hard. And so to answer your question, no, we have not done anything specific with it, but we were really curious about, can you early predict dropout and what could be the strategies to put into place to prevent this? But yeah, there's other hurdles involved in conceptualizing this well.
Yeah. Okay. Thank you.
Thanks for the question.
Thanks. Lorenzo, you had a question?
Yes. It's probably a bit of a selfish question because in my PhD, I'm working in the domain of explainability, essentially. And it is something, one of the things that you touched upon in your presentation. I was wondering whether or not there is like a room to see sort of explanations, how can I say this, like as if they were just another sort of data point that can actually sort of align with what you get with these clinical questionnaires or disagree with those. I know, let's say, the first thing that comes to my mind is that, okay, it's a bit tricky considering this preference for simple visualizations and stuff, and then it's like you're trying to cram too much into a simple bar, into a simple UI. But I was just curious if there is sort of like a room to adapt.
No, absolutely. And I presented it sort of as much as it's a choice, whether you want to go with binary or something more complicated. And partly it is, and it has been a consideration for, you don't want to be too risky and you rather leave interpretations to the professionals. However, we have experimented, of course, with could we provide insights that would be richer, that could lead to clinically more useful actions, or at least inform them in more meaningful ways. So, for example, we experimented with feature explanations. So which of, let's say, the PHQ-9 questionnaire has 9 items, which of these at any moment in time at most changes perhaps in scores explain the prediction outcome? Is it that there might be somebody constantly having sleep difficulties and that's at the core for why they're not improving? And if you knew that, maybe you want to unlock the sleep module. So that's, in theory, sounds like, oh, this is a really plausible thing, maybe we should go after it. But when we tried to model it, it wasn't that human legible. What the most salient features that explain the prediction might not be easily linked with how people really responded. And that made it actually more confusing than helpful. We also explored, could we throw in loads of engagement data? So as a sort of combination of how people engage and their mental health scores, could we say that certain types of engagements might link to explaining a prediction outcome? And again, you know, making really good sense of it was really difficult. Like, where more often than not, we would find insights that we weren't sure would be human interpretable and actionable in a way that really helped rather than confused, and that would have needed probably a lot more work. But it's not to say that these aren't very valuable avenues to go after. But I think it sometimes needs different ways in which you might collect the data, have assumptions about what are you actually trying to answer through that data, and build that into the predictions you want to ultimately create for people, rather than here's any sort of interaction data and you're trying to post hoc identify meaning within it, and then that can become quite difficult. That was one of the experiences we had.
No, I see. This is one last thing. It's also interesting because it's basically the same discussion that we've been having with Jay for a while. That sometimes what you get with these methods are, let's say, explanations in their own definition and not necessarily ours, like as people definition of explanation. But yeah, exactly. I see there are other people that want to ask questions, so thank you for the answer in the meantime.
Yeah, I actually have a follow-up question, but I would just to be to have other audiences to first have chances to interact with Anja. Camille, sorry, Chada, you have spoken already, so but I want to give it back to you.
First of all, thank you very much for the interesting talk. I was wondering a little bit. I see several similar studies that work with the PHQ-9 and the GAT-7, and as you mentioned, these are very generic questionnaires. And within clinical psychotherapy and clinical psychiatry, sometimes more personalized goals and more personalized outcomes are used. And I was wondering, can we do something similar with machine learning, or can we, for instance, I don't know, I'm not very, I come from a more clinical side, so I might be asking an unexperienced question here, but can we, for instance, develop through an unsupervised method goals of participants, look for more abstract common features, and then make a similar model for that instead of the very generic questionnaires like the GAT-7 and the PHQ-9?
I might answer your question slightly differently. I think when it comes to intent and goals, I sometimes wonder, rather than trying to model what that might be for a person, can we not ask the individuals and maybe share that with us in other ways that isn't just standardized clinical questionnaires? But then perhaps thinking about other ways in which machine learning could be useful. I've seen, for example, examples where as you write answers, for example, and since this group is also focusing on text and language models, there might be things that you could pick up quite well in terms of symptoms that's more nuanced from the text and how things might change. So there's been at least one piece of work that I'm aware of that was looking at, as you go through treatment and you write, and the way that you might write about yourself changes as your view and your thinking changes because you're adapting your thinking, and that you can actually pick up on that quite well from the language markers over time, even outside of sort of like a clinical standardized point of view. So for example, people might be quite harsh to themselves. I should be doing this. I let other people down. You know, there's a lot in the way that you position yourself and how you write that can indicate, oh, you're probably giving yourself a hard time. Maybe self-esteem is an issue. And you don't even need to necessarily label things like that. It could be a lot more subtle. And I think there's a lot that could be done that doesn't even create necessarily so much burden on individuals to have to engage with clinical questionnaires. I mean, for example, the 9th item of the PHQ-9 is asking about intent to self-harm or hurt yourself. You know, these can be quite triggering potentially questions as well. Is there other ways in which we can leverage what people reveal about themselves? I'm sure there's a lot more that could be done there, but it's sort of always about finding data user, identifying data users that people find acceptable, you know, revealing or even providing, for example, let's say a diary you keep about yourself, about your mental health for data analytics purposes, you know, that is appropriately anonymized is very tricky. So sort of also building trust with, can I understand what the advantages of those data approaches are to me, that I am open to sharing this kind of data, very personal data about myself more externally, for people to do that kind of data work. I think that's sort of always a bit of a balancing act as well, especially mental health. Thank you.
Thanks. Chada, you want to follow up?
Yes, you spoke a little bit, well, you spoke quite a bit in phase 3 about your insight from practitioners, but not so much for phase 2, when you were still talking about how they were sending messages to users. And I'm curious, you know, what kind of insight you got there about how they were interacting with the pre-existing system.
Well, they weren't using it yet. It was more of insight gathering exercise, like if you had access to this prediction, this is how it works. If you had access, how would it need to be presented, and how would you use it to inform how we go about the integration into service? So it's not that I have any insights into how they would actually use the intervention. That would come out from the RCT that has been conducted. So I haven't measured any sort of over or under trust with regards, for example, to increase transparency of the system. But there is research out that suggests, so again, another fine balance between the more explanations you might provide or context of the system, even if that is false, it can almost create more trust in it. So you can rely more on something that is supposedly more transparent when it can still be false, right? So it's like how much explanation, the more explanation you give, the more you just think, okay, explain to me why it does it. So I should trust it even more. It's not always necessarily the mitigation strategy that makes a difference. And I guess that's why we were focusing on like human mitigation strategies, other information outside of the model output. How can you triangulate the assumptions you are making with other types of data and other insights you know about this person as a way to keep questioning, should I trust this or not, rather than explaining the explanation more within what could or could not be true or false, and create skepticism in a way, or like a more appropriate handling of what, it's almost like designing for it. It occasionally gets it wrong, and you know that, and then trying to be useful with that nonetheless by triangulating it with other types of knowing. That seemed like a more appropriate approach in this context. It's not to say that in other contexts other things might not be better. Yeah, and we've not done any systematic study of that at all, so I can't say much more about that.
Thanks, Anja. And I actually have a question. So it's related to the explainability and the reliance of users in this context, the supporters. We actually, so in some of the work that we did, we actually also find that it's quite difficult to make sense of the explanations provided by those explainable AI methods. Yeah, like you said, Anja, right? A lot of times it's difficult to align it with human understanding of how things why a certain decision should be made. So from your concrete experience, right? So do you see chances, let's say, for those explanations to make more sense by potentially, for example, giving a bit more support to the user? In terms of interpreting the explanations, or you see it's actually more a challenge on the computational side. Those methods that we develop for explainable AI, they need to do a better job to make the explanations easier to interpret.
I would say, again, it depends a little bit on the context and the application. In some instances, you do need to have a little bit more of a technical understanding, and then educating and translating is really important. I think this is shown, for example, in our work, when we got to a point about, okay, here we've got a set of models and we think they're kind of quite robust predictors, and we were interacting with the clinical team. So how do you think they're good enough to be deployed? Well, how do they assess that? Like what ROC curve, what sensitivity, specificity is acceptable? And I think to have these conversations we've done analysis for different potential risks of bias, looking for different demographics and testing against that we don't unfairly discriminate, but you need in those conversations to translate and try and explain as much of the technicality that you can really have an informed conversation. How is it working? How to tune it, and so forth. I think the explainability methods are designed for that, right? To kind of understand, where's my model falling short? How can I improve it further? And there's value in that. And sometimes you want to bring the clinical team on into those conversations. There might be other types of explanations to develop, and sometimes I'm wondering whether it's more about being a lot clearer about what is the task that we're trying to achieve or what we're running predicting for, and then maybe going back and collect the data in other ways, doing sort of more equality, meaning related question, because we're often going about it almost like the wrong way. We have the data and then we try to have the insight. What's the insight we want to create? And then how we need to collect the data and the variance. And maybe then it's a more interpretable model with a clear sort of takeaway and a really high performance in the right context with actions that can be taken depending on different outcomes, that has the most clinical utility, but is perhaps not as ambiguous as deep learning outputs can often be. Yeah, so it's not a clear-cut answer. I think there is learning from both ends to be done, having a bit more sensitivity of what would be clinically actionable in this context of healthcare, and what insights to provide and to cater to that, and vice versa, bringing and educating clinicians into the conversation to help shape machine learning in responsible ways as well.
Yeah, indeed. Did you observe, let's say, in the previous experiment, right? Did you observe certain like human factors that can affect, for example, expertise, experience, those past experience ways, machine learning, data science in general, for example, right? Would that affect the people's or the users' acceptance of this, the advice given by the platform?
Can you say a little bit more what you mean?
So I was trying to understand a bit what affects, right, the uptake of these decisions from machines. If in your previous experiment, if you have observed anything specific, right, like for example, if the experience with data science or things like that.
I can only say our sample was already a little bit skewed in the sense that the people who were interviewed were quite open to working in a digital platform, working with data dashboards and to AI, and we're quite a little bit more on the optimistic, open-minded side, which I think is already somewhat a limitation. I think there might be others who are a lot more resistant and reluctant, and we didn't capture those viewpoints as strongly as we should have. Yeah, I feel like, yeah, I'm not sure I can derive anything usually that I felt like comfortable enough to share. It just needs a little bit more work to really say. I think tech acceptance, such a complicated question, especially in healthcare, and we are still, I would say, a long way off. There's a lot more work that really needs to be done step by step, and doing those steps carefully, I think, is perhaps a really important approach. And learn and have these conversations that get more into the context to do this work and learn of what maybe it's less about the technical capabilities. Sometimes it's more about, okay, we have already a great set of technical capabilities, a lot of things we can model, but what and how to make it work in context is sort of like a different question that we also need to go after and bring these worlds together a little bit more. I think that seems like a bigger challenge almost to me.
Exactly. I feel that even from the explainable AI perspective, right, a lot of methods are developed not for those use in specific context, and potentially bringing the perspective from the context or from the actual users might be very useful for even for the technical advances.
Yeah, absolutely.
Yeah. Cool. Do we have other questions from the audience? Since we are already a bit over the time, so I think then I would propose that we finish here. Thanks again, Anja. It's a great pleasure to have you here. Thank you so much for introducing the world amazing work and also the platform.
Oh yeah, thanks for having me, and thanks for all the questions as well. It's been really great discussion.
And thanks everyone for joining the Academic Fringe Festival. Next week we will have Arun Kumar speaking about the deepification of machine learning and AI. So see you next week.